Stats class. So today you have a couple of past exam questions. This first one here is testing your understanding of working out median, lower quartile, and that sort of thing. So you've got this data here, and we need to find the median and we need to find the interquartile range. So the first step we want to do here obviously is arrange this data in order. Okay, now to find the median, we simply need to find halfway. So there are 12 items of data, 2, 4, 6, 8, 10, 12. It's going to be between the, it'll be between the 6th and 7th because 12 divided by 2 is 6. Therefore, mean of 6th and 7th items of data. 3, 4, 5, 6, 7, so we're taking these. So the median is equal to 51. Now the IQR, we need to find our lower quartile. So for our lower quartile, we're going to find a quarter times 12 is 3. So we're looking at the mean of 3rd and 4th items of data. 3, 4. So our lower quartile is therefore going to be 40. We're going to try the same with the upper quartile. We find this using the 3 quarters times 12, and that is going to be 9. And so we're looking at the mean of 9th and 10th items of data. 3, 6, 9. So 55 plus 60 divided by 2, which is 57.50. The last part, so you want to show this working that you've got here. The last part is the interquartile range, and that's going to be this subtract this, which is 17.50 or 17.5. That's the first part of the question. The second part of the question is asking us, what is the disadvantage of using mean as a measure of central tendency in this particular case? Now, if you look at this data here, you can see that we have what we probably could say is an outlier here. And as we know with means, if you have something that is an extreme value, such as 110, it's going to pull your mean in that direction. So our mean, or our measure of central tendency in this case, is going to be pulled higher than it really is. So you would need to say something like, the disadvantage of using a mean in this case is that it is going to be impacted by the outlier of 110, which is an extreme value. Well, I hope that makes sense. Let's move on to question 2. So in our second question, guys, we have Benju cycling to work each morning, and he's got 2 possible routes. He chooses the hilly route with a probability 0.4 and the busy route with probability 0.6. So we've got to use a tree diagram to analyze this, I think. So here's Benju. If he takes the hilly route or the busy route. The hilly route was a probability of 0.4 and the busy route was a probability of 0.6. So that's the first step. If he chooses the hilly route, the probability that he will be late for work is x. So we'll say late, x, and therefore not late would be 1 minus x. We'll say not late. However, if he chooses the busy route, the probability that he'll be late for work is 2x. So we'll say here this is 2x for late, and this one is 1 minus 2x for not late. Okay, so that's what it looks like, and we have to show that, and the last piece of data is that the probability that he's late, is 0.36. Now, how are we going to show this? Well, if we look at our diagram here, you can see that there are 2 ways he can be late. This way and this way. So therefore we know that 0.4 times x plus 0.6 times 2x, which is 1.2x, equals 0.36. Therefore, 1.6x is equal to 0.36, and x is equal to 0.36 divided by 1.6, and x is equal to 0.225. So that's the answer to the first question. Now, the second question asks us this. It says, given that he is not late for work, given he's not late for work, find the probability that he chooses the hilly route. So we've got to write this with our technical formula, set theory formula. So probability, now it says given that he's not late. So given not late, find the probability that he chooses the hilly route. So probability hilly given not late. And we can say that this is equal to the probability of hilly intersection not late divided by the probability of not late. What's the probability of hilly intersection non-hilly? Right? In other words, we're not non-hilly. What is the probability that he takes the hilly route and also that he's not late? So hilly route not late, that's this here. Okay, so that's going to be 0.4 into 1 minus 0.225, which is what we found out on the first question, that x is 0.225. Divided by the probability that he's not late, well, that's going to be this and this. So we've got to have on the bottom this plus this. Now, we know that the probability that he's late is 0.36, so the probability that he's not late must be 1 minus this, so we could say 1 minus 0.36. Chuck that in your calculator, and what do you get? I get 31 over 64. I hope that makes sense of these questions. I hope that you didn't find them too difficult. If you do have any questions, feel free to email me and I can hopefully clarify them for you.